parabola. Now with the parabola, what you get is you get your function. Let's just write a function for a parabola there, which is equal to 3 bracket x minus 5 squared plus 6. Now this is what a parabola equation would look like if it's in its simplest form for you to see quite easily. Obviously there are two versions of this, and I'll show you the other version after this one. Now with this one, it's quite easy. The first thing you do is to determine the special property. So our special property in a parabola is the turning point. And that one is found by just looking at the equation. If you look in the bracket there, you'll get x. Remember we said if they're in the same bracket, it's x minus 5, so it's going to be x is equal to 5. And the y ordinate will be at y is equal to positive 6. So the turning point in this particular parabola is actually going to be 5, 6. After you've found the turning point, the next thing you're going to do is to find the line of symmetry. Again, our equation is f of x is equal to 3 bracket x minus 5 squared plus 6, and the line of symmetry is obtained from the equation just by inspection also, and it is the x ordinate of the turning point. In other words, if you can find the x value of the turning point, then you can get the line of symmetry. In this case, it's x is equal to 5. Now, once you've done that, the next thing you want to do is to find your intercepts. And our first intercept is when x is equal to 0 as usual. And you substitute. And when you substitute, you're going to get f of 0 is equal to 3 bracket 0 minus 5 squared plus 6. And if you press your calculator, just press it the way it is, this will be 81. So our first intercept is 0 for x ordinate and 81. Please make sure you write it as a point. Now to find the y-intercept, our function is x is equal to 3 bracket x minus 5 squared plus 6. So intercept, so let's find the intercept there. Y is equal to 0 to find the x-intercept. So we make 0 there. 0 is going to be equal to 3 bracket x minus 5 squared minus plus 6. And if you take the 6, it will be negative 6. 3 bracket x minus 5 squared. And then if you, this will become, divide the 6 by the 3 to get minus 2 is equal to x minus 5. And the working is pretty much the same. But now, when we get here, we cannot find the square root of a negative. So it means that the x-intercepts do not exist for this particular function. We will have to work out one where it exists so that at least you can see. So we now know that the x-intercept doesn't exist, and we can now sketch our graph. Remember, we have got our line of symmetry. Our line of symmetry from what we worked out was x is equal to 5. Our turning point was 5 and 6, we've got 5 and 6 from our turning point, and our y-intercept 0 and 81, if I remember correctly. Yes. So now we need to just sketch this graph. For us to sketch this graph, we need to first of all draw the line of symmetry. Our line of symmetry is at x is equal to 5, so I'm just going to draw the line of symmetry there. At x is equal to 5, there is my 5, I'll put it in red, but we don't have to struggle to see it. That's the line of symmetry. Then I'm going to mark the turning point. The turning point is at 5, 6. I'm just going to put the 6 somewhere here. So there is my turning point. Now to sketch the graph, and my intercept is at 81, so I'm going to mark the intercept. Let me just mark the intercept. I'm not putting it too far away. This is not drawn to scale, so don't worry about the scale and how 6 looks very close to 81. It's just a sketch, so you don't have to worry about scales as long as they are on the right side in terms of their position in terms of numbers. So now I can draw the parabola. Here it goes, the turning point. It passes through the intercept, the y-intercept, and then it turns. This is a parabola. Now, let's have a parabola which we can find other values. Like for instance, if I had f of x, I'm going to try and use the same values so that we don't move too far away. 3 x minus 5 and then squared minus 27. Now I put a minus there. The other time it was a positive. That's why we couldn't find the other intercept. Now our line of symmetry again, let's write down our line of symmetry. Our line of symmetry is going to be x is equal to 5. Our turning point, when you look at it, it's going to be x is equal to 5, y is negative 27. So it's going to be that one. It's going to be 5 and 27. Negative 27, because there's a negative there. Here the sign changes because x and the number are in the same bracket, as you can see. And now we're going to find our x-intercept, the easiest one. So the y-intercept, sorry. So the y-intercept is the easiest one. The y-intercept, and that's when x is equal to 0. So this will give us, if you let me just show you how I would use the calculator here. So let me just show you how I would use the calculator. So first of all, let me just put f of 0 is equal to 3 bracket 0 minus 27, then squared not minus 27, this is minus 5 squared minus 27. So I need to get this on my calculator. I'm just going to go and refer to my calculator because it's much easier. It's going to be much easier with the calculator. So let's use the calculator there. So with the calculator, it's 3 bracket 0 minus 5 close bracket squared minus 27. And this is going to give me 48. So I'm just going to go back. So we got 48 there. So our intercept is going to be 0 for x and 48 for y. Now I'm going to move on to find the x-intercept. And y is equal to 0. which means that 0 is equal to 3 bracket x minus 5 squared minus 27. And the 27 will come here to become 27 is equal to 3 bracket x minus 5 squared, and then divide both sides by, divide the other side by 3, you get 9 is equal to x minus 5. That's how the 3 goes to the other side. This 3 will come and divide this side. So that you get 27 divided by 3 is 9. Then you find the square root of 9, which is going to give us two answers, plus or minus 9. And this is going to give us x minus 5. Then this is plus or minus 3. Then you add 5 is going to give us our x. So in a nutshell, our values for x are x is equal to 8 and x is equal to 2. So our intercept, just got two intercept. The first one is 8, 0, and the second one is 2, 0. Now let's go and plot our graph now. Remember, we must start with the line of symmetry. So our line of symmetry, remember, if we can go back, is x is equal to 5. So let's go and put x is equal to 5 on the graph. Just use a different color there. So x is equal to 5. So there you go. Put x is equal to 5 there. And then using the red color, we put 5 there. And our turning point was 5 and negative 27. So I'm just going to put negative 27 there. So remember, let's just go back so that you can see. See 5 and negative 27. So we go back, then we got our turning point, our intercept. Then let's now put the intercepts. The intercepts, we have got 8, 0, 2, 0. So let's go and mark 8, 0. 2, 0 is going to be somewhere here. 2 there, that's 2, 0. 8, 0 is going to be somewhere here. Let's put 8 there. That's okay. Doesn't have to be very accurate. And then finally we need to put the last intercept, which is this one here, 0, 48. And then that's 0, 48 will then come somewhere up here. I put my 48 somewhere there. Now I can then join the graph turning point, passing through the intercept, passing through the y-intercept. There is this turning and it goes up, and that's a parabola. Again, a parabola can be shifted like the other graphs, but now I'm not going to explain in detail. You need to watch the videos on the hyperbola and the straight line. So a shift in the left, let's say 3 units, left would mean that we have got f of x. Because it's left, it's plus, going to put a plus sign there, and then 3. Then maybe that we call h of x. Then you can always substitute to get the equation. So we know our equation was 3 bracket, but where there was x, we put x plus 3. Can you see? And then we can continue with our equation the way it was. There was a minus 5 there, then squared, then minus 27. Do you see? I'm now shifting this graph. All I have to do is, for me to get the equation, it's x3 bracket x minus 2 squared minus 27. That becomes your new equation. Let's now look at shifting 2 4 units to the right. We just picked 4 units. So again, this one will give us P of x. It's going to be giving us f of x minus 4. Because it's now going to the right, you must say minus 4. And this would result in your 3 bracket. And our x is replaced by x minus 4. Like that. And the minus 5 is there. Then you square minus 27. This would eventually give you 3 bracket x minus 9 squared minus 27. Then we go and talk about shifting up and down 8 units up. Now, if we are shifting 8 units up, let's say it's h of x, it means that we are just simply taking our f of x. Because it's up, we just say plus. Can you see it's different? The plus sign is not going with the x. It's plus 8 there. Which means that we can then write our function f of x, which is 3 bracket x minus 5 squared minus 27. And then because we are going up plus 8, which would then give us 3 bracket x minus 5 squared minus 19. That means the graph has shifted up. The graph can also be shifted down. Let's just say 5 units down, or let's say 20 units down. 20 units down. What would happen there? So this would give us P of x is equal to f of x. Remember, don't put anything there, but it's because it's going down, it's minus 20. So this would give us 3 bracket x minus 5 squared minus 27. And then because it's going down, we must subtract 20 there. So this will give us 3 bracket x minus 5 squared minus 47. That becomes your new graph after you have shifted it. Now let's look at the next thing which we want to do, and that is range and domain. Now if you look at the parabola, and we only drew a parabola which let me give you another perspective in terms of the parabola. Let's say we had a parabola which was like this, so that we don't generalize things. And then there you go, it cuts the y-axis there, it cuts the x-axis there. So let's say this is our parabola, and this is the turning point. The turning point is going to be maybe, I'm just going to use a purple color there. So this is 5, and let's just put 20. So the turning point here is 520, like that. Right. So with the turning point, and these are your intercepts, but we don't really want to care much about them. We just want to talk about the range and the domain. So the domain, for instance, in a parabola, usually it's x an element of all real numbers without other conditions. So the domain is very simple. As you can see, the graph is going to go to infinity in terms of x and y, and it's continuous. There is no breaking, there is no asymptotes. It's just going to be x an element of real number. But the range now, the range is a bit different. Now, can you see this graph is that the range, the maximum value is 20, but it goes all the way down. As the graph is going down, I'm just going to show you, the graph is going down, and it's going to go down to infinity. So it's going to go down to negative infinity. So we are going to say it's x an element of, because it's going down, it's negative infinity going all the way up to the maximum value, which is 20. That's the range of the parabola. And when you look at this one, because I drew one which was facing down, if it had been facing down up like this, and let's say this would have been 230, for instance. Our turning point is 2 and 30. Now 30 is the minimum value of y. In other words, if you look at your Cartesian plane, there you go, there, 30 will be somewhere here. That's the minimum value of the graph, and it means that the graph does not, if you look at the graph here, the graph does not exist down here. It goes from this point going up. Can you see? So I would then say the range for this one is x, an element of, starting from 30, you must put square brackets there, and going to positive infinity. So we just say positive infinity. Infinity always has round brackets. And let me just go back there just to stress that this one should have been a square bracket to show that it includes the 20. So we must not make that mistake. So here, infinity, it's positive infinity. Positive infinity is to the right. So that's how we look at the range and the domain. So now let's look at the next one. It's going to be the inverse. The inverse is also another one which we need to remember. Remember, the inverse is also a reflection on y is equal to x. Remember, it's a reflection, so I'm just going to reflection. So it's a reflection on y is equal to x. And when you look at your inverse, in this case, let's take our function. If we wanted the inverse of this function, is equal to 3 bracket x minus 5 squared minus 27. If I wanted the inverse of this, I'll start by swapping. The x goes where there is the f of x, which is the y, and then the 3, the y goes, let me just put the ones with the normal ones in their normal color. So there is the x replacing the f of x, and this is going to be equal to 3 bracket minus 5 squared minus 27. So the y will come where the x was, like that. That shows that I'm now trying to find the inverse. And obviously now you have to play around with the equation. So let's just play around with this equation. First of all, we remove the 27, so it's going to be plus 27 on this side. And then after that, we remove the 3. Let me just do it in slow motion so that you can see 3 bracket y minus 5 squared. Then now we need to remove this 3, it goes this side to divide. So it's going to be x plus 27 divided by 3 is equal to y minus 5 squared. So once I've done that, it's x plus 27 divided by 3 is equal to bracket y minus 5 squared. So to remove the squared, we find the square root of that whole thing. X plus 27 over 3 is equal to y minus 5. Then to find our y inverse, so when we are finding this one, it becomes y inverse, like that, is going to be equal to square root of x plus 3 divided by, plus 27 divided by 3, then it's going to be plus 5, like that. This gives us the inverse function. The same thing when we are now drawing the inverse function of the graph. Okay, so finding the equation is not difficult. Now let's look at the graph. Suppose, say, we are drawing the inverse function of this one here. Let's go to one where we had found all the points. This one. Let's look at how we would draw the inverse function of this graph here. Remember, x is equal to 5 is the line of symmetry. So, if x is equal to 5 is my line of symmetry, it means that I must create a y is equal to 5 for my other graph's line of symmetry. So there is my line of symmetry graph for the inverse, and it's at y is equal to 5. Can you see? That's my line of symmetry. Now, there is a point 2 where x is cutting where the x-axis, the point which is on the x-axis is 2, so it must go to the y-axis, and that will be 2. And then this 8 will also go to the y-axis, that will be 8, like that. Then this 48 will also go to, it's on the y-axis, so you need a 48 on the x-axis there. So we need a 48 on the x-axis. And then lastly, the 27, you need a 27 there. So if you need a negative 27 on the y-axis, will become negative 27 on the x-axis. And then when you now draw the graph, the turning point was 5, negative 27. Now it's negative 27, 5. So when I'm drawing it, I'm drawing the graph. There you go. It must cut there at 48, and then it must turn, and that's the inverse of the parabola. It always looks sideways, either to the left or to the right. And the way I drew it is I was just reversing the points. And apart from that, that's how we do the parabola.